Hello and welcome to our channel, Web3 Reviewer.
Today we're taking a deep dive into Ethereum.
Oh yeah, it's a topic that a lot of people find confusing.
Yeah, shrouded in technical jargon.
Exactly.
So our mission today is to demystify Ethereum and make it understandable for everyone.
Yeah, even if you're a complete beginner.
Exactly. Even if you're just starting to explore the world of blockchain and cryptocurrency.
So if you've ever wished you understood how cryptocurrency really works,
You've come to the right place.
stick around. We'll uncover what makes Ethereum unique, how it works, and why it's generating so much excitement.
We'll also delve into its real-world applications, from revolutionizing finance to empowering artists and transforming supply chains.
So let's start with the basics. What exactly is Ethereum?
Imagine a global computer,
Okay,
accessible to anyone, anywhere in the world. That's the essence of Ethereum.
so it's like a giant shared computing platform.
Precisely. And instead of being controlled by a single company or government, it's powered by a decentralized network of computers.
That's where blockchain technology comes in, right?
Exactly. Blockchain is the foundation of Ethereum. It's a secure and transparent way to record and verify transactions without the need for intermediaries.
So it's like a digital ledger that everyone can trust.
A perfect analogy. And one of the key innovations that sets Ethereum apart is its ability to execute smart contracts.
Smart contracts.
Yeah.
Okay, that sounds futuristic. Can you break it down for us?
Think of it like a digital vending machine.
All right.
You input your money, select your item, and the machine automatically dispenses it based on pre-programmed rules.
So it's like automating agreements without the need for lawyers or paperwork.
Precisely. Smart contracts eliminate the need for middlemen and ensure that transactions are executed fairly and transparently.
Can you give us a real-world example of how smart contracts are being used?
Absolutely. Let's say you want to rent an apartment. With a smart contract, you could pay your rent online and the apartment door would automatically unlock for you at the agreed-upon time.
Wow, that's convenient and secure. No more dealing with lost keys or security deposits.
And that's just the tip of the iceberg. Smart contracts are being used to streamline supply chains, create decentralized marketplaces, and even facilitate tamper-proof voting systems.
This is incredible. I'm starting to see how Ethereum is more than just a cryptocurrency.
It's a platform for innovation and a catalyst for creating a more decentralized and equitable world.
If you're finding this deep dive into Ethereum insightful so far, don't forget to subscribe to our channel, Web3 Reviewer, now.
Now let's take a closer look at the building blocks of Ethereum. One key concept is Ethereum accounts.
Okay, accounts. That sounds familiar.
Yep.
Are they similar to bank accounts?
In some ways, yes, Ethereum accounts hold your Ether, which is the cryptocurrency native to the Ethereum network.
That's like your digital wallet.
Exactly. But Ethereum accounts are more than just storage for your funds. They also have unique features that enable interactions with smart contracts.
Could you explain those features?
Each account has a balance which represents the amount of Ether you own, but it also has a nonce, which is a security feature.
A nonce? What's that?
Think of it as a counter that ensures each transaction is unique and prevents double spending.
Ah, so it's like a safeguard against fraud.
Precisely. And then we have code and storage, which are essential for interacting with smart contracts.
So Ethereum accounts are like mini programs that can execute transactions and interact with the blockchain.
That's a great way to think about it. And there are two main types of accounts: externally owned accounts, EOAs, and contract accounts.
Okay, let's unpack that. What's the difference between these two types?
EOAs are controlled by individuals like you and me. We use private keys, which are like passwords to access and manage our funds.
And contract accounts.
Those are controlled by code, specifically the code of smart contracts. They act autonomously based on predefined rules.
So it's like having a robot managing certain transactions for you.
That's a great analogy. EOAs initiate transactions while contract accounts execute them based on the logic of the smart contract.
Now let's talk about how these accounts actually interact with the Ethereum network. What happens when I want to send Ether or interact with a smart contract?
That's where transactions come into play. Think of a transaction as a request to change the state of the Ethereum network.
Okay, so if I want to send Ether to someone, I'm essentially requesting that the network update our balances.
Exactly. And these requests are bundled together into blocks and added to the blockchain, which is the permanent record of all transactions on the network.
So the blockchain is like a giant immutable ledger.
Precisely. And to process these transactions and add new blocks to the blockchain, Ethereum uses a mechanism called gas.
Gas, like the fuel we put in our cars.
Well, it serves a similar purpose. Gas is a unit of measurement that represents the computational effort required to execute a transaction.
So the more complex the transaction, the more gas it consumes.
Exactly. And users pay a gas fee for each transaction, which incentivizes miners to process transactions quickly and efficiently.
So gas is like a fee for using the Ethereum network.
Think of it as a way to prevent spam and ensure that only valuable transactions are processed.
This is starting to make sense. So we have accounts, transactions, and gas. But how does Ethereum ensure that all this information is secure and tamper-proof?
That's where the magic of blockchain technology really shines. The blockchain is designed to be incredibly secure and resistant to attacks.
How does it achieve that?
Each block in the blockchain is linked to the previous block, creating a chain of information that is virtually impossible to alter.
So if someone tries to tamper with the transaction, it would disrupt the entire chain.
Exactly. And because the blockchain is distributed across a vast network of computers, it's incredibly difficult for any single entity to control or manipulate it.
That's impressive. It sounds like Ethereum has a lot of safeguards in place to ensure security and transparency.
It does, and that's one of the key reasons why it's gaining so much traction across various industries.
This is truly fascinating. We've covered a lot of ground already, and I'm sure our viewers have a lot to process. If you're enjoying this deep dive into Ethereum, make sure to leave your questions and thoughts in the comments below.
We love hearing from our community and engaging in insightful discussions.
Now let's delve into what truly sets Ethereum apart from other blockchain platforms. One key feature is its Turing completeness.
Turing completeness means that Ethereum's programming language is incredibly flexible and powerful. It can handle complex logic and computations, allowing developers to create a wide range of sophisticated applications.
So it's like giving developers a blank canvas to build anything they can imagine.
A perfect analogy. Unlike some other blockchains that are limited to simple transactions, Ethereum can handle complex programs and algorithms.
Can you give us an example of how this flexibility is being used in practice?
Absolutely. Imagine a decentralized application that allows you to automatically invest a portion of your income into a diversified portfolio of cryptocurrencies based on your risk tolerance. That's something you could easily program on Ethereum.
Wow, that's impressive. It's like having a personal financial advisor powered by code.
Another key differentiator is Ethereum's transition from proof of work to proof of stake.
We touched upon proof of work earlier, but how is proof of stake different?
Proof of work, which is the original consensus mechanism used by Bitcoin, involves miners solving complex mathematical puzzles to add new blocks to the blockchain.
It's like a computational arms race, and it consumes a lot of energy.
Exactly. Proof of stake aims to address this issue by relying on validators who stake their ether as collateral to participate in the consensus process.
So it's like putting your money where your mouth is demonstrating your commitment to the network.
Precisely. Validators are chosen to propose and validate new blocks based on the amount of ether they have staked.
And this transition to proof of stake is expected to make Ethereum more energy efficient.
Absolutely. It eliminates the need for energy-intensive mining, making Ethereum much more environmentally friendly.
That's a significant improvement.
Hmm.
So we have Turing completeness and proof of stake. What else makes Ethereum stand out?
Well, we can't forget about decentralized applications, or dApps.
dApps, right? We mentioned them briefly earlier. but
Yeah.
Can you explain them in more detail?
dApps are applications that run on the Ethereum network, meaning they're not controlled by any single entity.
So they're like apps that operate outside the traditional app store.
Exactly. And because they're built on the blockchain, they inherit all its benefits: transparency, security, and immutability.
That's incredible. Can you give me some examples of what these dApps can do?
Absolutely. One exciting area is decentralized finance, or DeFi.
DeFi, I've heard that term thrown around a lot lately.
It's essentially a revolution in how we think about financial services.
So instead of relying on banks, we can use dApps to manage our finances.
Precisely. For example, imagine being able to borrow money without going through a bank using your cryptocurrency holdings as collateral. That's something DeFi makes possible.
Wow, that's game-changing. What other cool dApps are out there?
The possibilities are endless. We have games where players truly own their in-game items, voting systems that ensure tamper-proof elections, and even platforms for creating and trading digital art.
It sounds like dApps have the potential to disrupt almost every industry.
They absolutely do. Ethereum provides the foundation for building a more decentralized and equitable future.
This is mind-blowing. Before we move on, let's take a closer look at how some of Ethereum's key features work in practice.
A great idea. Let's start with the state transition system, which is how Ethereum keeps track of changes on the network.
Okay, I'm all ears. Explain it like I'm 5.
Imagine you have Alice and Bob, each with a certain amount of ether. When Alice sends some ether to Bob, the state of the network changes.
It's like a digital game of hot potato where the ether's the potato.
A fun analogy, Ethereum keeps track of these changes using a concept called state. The state represents the current balance of all accounts and the data stored in smart contracts.
So each transaction triggers a change in the state of the network.
Exactly. And the beauty of the system is that every change is validated and recorded on the blockchain, ensuring accuracy and transparency.
That's reassuring to know. What about Merkle trees? That's intriguing.
Merkle trees are a clever way to organize and verify data on the blockchain.
Okay, paint me a picture. How do they work?
Imagine a family tree. At the bottom, you have all the individual family members. As you move up the tree, each parent node represents the combined information of their children.
So it's like a hierarchical structure that summarizes data efficiently?
Precisely. And in the context of Ethereum, each block in the blockchain uses a Merkle tree to organize all the transactions within that block.
So it's like creating a compact fingerprint of all the data in a block.
That's a great way to put it.
Mm.
And this fingerprint allows for quick and efficient verification of information. If you want to check if a specific transaction is included in a block, you don't need to examine the entire block. You can simply follow the path in the Merkle tree.
That's incredibly clever. It's like having a shortcut to verify data.
And finally, let's not forget about decentralization, arguably the most fundamental feature of Ethereum.
Decentralization. We've mentioned it throughout our conversation, but why is it so important?
Well, remember how we talked about Ethereum being like a global computer owned by no one? That's decentralization in action.
So instead of relying on a single company or government to control the network, it's distributed among a vast network of computers worldwide.
Precisely. And this distributed nature makes Ethereum incredibly resistant to censorship and outages.
It's like having a backup generator for the internet.
That's a great analogy. Even if one computer fails or a group tries to manipulate the network, the rest of the system keeps running.
Wow, that's incredibly resilient. It's like a digital fortress built on collaboration.
Exactly. And that's what makes Ethereum so powerful. It empowers individuals and communities to take control of their data and build systems that operate outside traditional structures.
I think we've laid a solid foundation for understanding the core principles of Ethereum.
Indeed, we have. But this is just the beginning. In the next part of our deep dive, we'll explore the real-world applications of Ethereum in more detail.
We'll see how it's transforming industries like finance, art, and even identity management.
So stay tuned for more exciting insights, and don't forget to subscribe to our channel, Web3 Reviewer, now for more insightful explorations into the world of blockchain and beyond. Welcome back to our deep dive into the fascinating world of Ethereum. We've laid out the foundation now. Let's explore how this technology is shaping the real world.
Yeah, I'm particularly intrigued by decentralized finance, or DeFi. It seems like everyone's talking about it. What's all the hype about?
Well, DeFi is about reimagining financial systems, moving them away from centralized institutions and onto the blockchain.
So instead of relying on banks, we could use dApps for things like loan savings and even trading.
Exactly. DeFi platforms allow you to borrow and lend money using cryptocurrency as collateral, all governed by smart contracts.
What's fascinating is the potential for greater financial inclusion. People who might not have access to traditional banking could participate.
That's right. That's one of the most exciting aspects of DeFi. It's about empowering individuals and creating a more equitable financial system.
But wouldn't removing intermediaries also introduce new risks?
That's a valid concern. With DeFi, you're responsible for managing your own assets and understanding the complexities of smart contracts. There's no central authority to fall back on.
So it requires a certain level of knowledge and caution. Tell me, what else can Ethereum do beyond finance?
Okay, let's shift gears to a world where digital ownership has revolutionized the world of non-fungible tokens, or NFTs.
Ah, NFTs. They become a cultural phenomenon. But I still struggle to grasp what makes them so unique. Isn't it just digital art that anyone can copy?
Well, that's where the blockchain comes in. An NFT represents ownership of a unique digital asset, be it art, music, or even virtual real estate. That ownership is recorded on the blockchain, making it verifiable and tamper-proof.
So it's like having a digital certificate of authenticity for a one-of-a-kind item.
Exactly.
Right.
And that's what gives NFTs their value. Think about owning the original digital file of a viral meme or a piece of art that gains immense popularity.
Right. I can see how that would appeal to collectors. What other applications are there for NFTs?
NFTs are being used for event ticketing, where each ticket is a unique token preventing counterfeiting. They're also being used to represent ownership in online games, giving players true ownership of their in-game items.
It's interesting to see how NFTs are blurring the lines between the physical and digital worlds.
Absolutely. And let's not forget about the potential of Ethereum for creating more secure and private identity systems.
That's a topic I'm really interested in. How could blockchain technology improve how we manage our identities?
Imagine storing your digital identity on the blockchain, things like driver's licenses, medical records, even educational credentials.
So instead of carrying around physical documents or relying on centralized databases, we could have a secure and portable digital identity.
Precisely. And that identity could be selectively shared with service providers, giving individuals more control over their personal information.
That would be a game changer for online privacy and security. No more worrying about data breaches or identity theft.
It's a vision that many developers are working towards, leveraging Ethereum's decentralized and secure nature.
I'm sensing a pattern here. Ethereum seems to be all about empowering individuals and creating more transparent and equitable systems.
That's a great observation. Let's move from the individual to the global scale and look at how Ethereum is transforming supply chain management.
Okay, supply chains can be incredibly complex. How can blockchain technology make a difference?
Imagine being able to track the journey of a product, say, coffee beans, from the farm where they were grown to the cup you're drinking from.
Yeah, that would provide incredible transparency. Consumers could make more informed choices about the products they buy.
Exactly. With Ethereum, each step in the supply chain can be recorded on the blockchain, creating an immutable record of the product's journey. This can help verify the origin of goods, ensure ethical sourcing, and prevent counterfeiting.
It's like having a digital passport for every product, providing a complete history and ensuring authenticity.
And that level of transparency can build trust between businesses and consumers, fostering a more ethical and sustainable global economy.
This is all incredibly exciting, but I imagine there are challenges to implementing these ambitious applications.
Absolutely. Ethereum, like any groundbreaking technology, faces its share of hurdles.
What are some of the key challenges that developers are grappling with?
One major challenge is scalability. As the network grows and more users join, it needs to be able to handle a large volume of transactions quickly and efficiently.
So it's like a traffic jam on the blockchain.
A good analogy. There are ongoing efforts to improve Ethereum's scalability, including solutions like sharding, which involves dividing the network into smaller, more manageable segments.
That sounds promising. What other challenges are on the horizon?
Energy consumption remains a concern, even with the transition to proof of stake. Developers are constantly exploring ways to further reduce Ethereum's environmental impact.
And then there's the issue of complexity. Understanding Ethereum can be daunting for newcomers.
You're right. The technology is still evolving, and there's a learning curve involved. However, the Ethereum community is incredibly supportive, with many resources available to help people learn and get involved.
This has been an incredible journey so far. I'm starting to see the vast potential of Ethereum to reshape our world.
We've only scratched the surface. As Ethereum continues to mature and evolve, who knows what amazing applications will emerge.
And that brings us to the final part of our deep dive. We'll explore the future of Ethereum, its potential impact on various industries, and the challenges that lie ahead.
We'll also discuss how you can get involved in this exciting space, whether you're a developer, an investor, or simply someone who wants to learn more.
We've covered a lot of ground, but if there's anything you'd like us to revisit or explore further, please leave your questions in the comments below.
We love hearing from our viewers and engaging in thought-provoking discussions. Stay tuned for the final part of our Ethereum deep dive.
Welcome back to Web3 Reviewer. We've journeyed through the intricacies of Ethereum, from its core principles to its real-world applications.
Yeah, we've seen how it's empowering individuals, reshaping industries, and really pushing the boundaries of what's possible in the digital world.
But like with any transformative technology, Ethereum faces its share of challenges and questions about its future.
Right. Let's address the elephant in the room: scalability.
We touched upon it earlier. Can you elaborate on why scalability is such a crucial hurdle for Ethereum?
As more users and applications flock to the Ethereum network, it needs to be able to handle a growing volume of transactions.
Right.
Without compromising speed or efficiency.
Okay, so imagine a highway suddenly flooded with 10 times the number of cars. Gridlock would be inevitable.
Exactly. That's why scalability is a top priority for Ethereum developers. They're exploring various solutions, such as sharding.
We briefly mentioned sharding. Can you break it down for our viewers?
Sharding involves dividing the Ethereum network into smaller segments called shards,
Okay.
each capable of processing transactions independently.
So instead of every node on the network having to process every transaction, the workload is distributed.
Precisely. This allows for parallel processing, significantly increasing the network's capacity and transaction throughput.
It's like adding more lanes to our metaphorical highway, allowing traffic to flow more smoothly.
Another challenge that's closely intertwined with scalability is transaction cost, often referred to as gas fees.
We discussed how gas is essential for preventing spam and incentivizing miners, but high gas fees can be a barrier to entry, especially for smaller transactions.
Yeah, that's true. If using Ethereum becomes too expensive, it could hinder adoption and innovation. Developers are working on Layer 2 solutions that aim to reduce gas fees without compromising security.
Layer 2 solutions. That sounds intriguing. Can you explain what those are?
Layer 2 solutions are built on top of the Ethereum mainnet, handling transactions off-chain to reduce congestion and costs.
Okay, so it's like creating express lanes on our highway, allowing certain transactions to bypass the main traffic.
A great analogy. These Layer 2 solutions can then settle their transactions back on the mainnet, ensuring security and finality.
So they offer a way to scale Ethereum without fundamentally changing its core architecture.
Exactly. It's an area of active development and innovation within the Ethereum ecosystem.
What about energy consumption? We know that proof of stake is more energy efficient than proof of work, but is there more that can be done?
You're right. Even with proof of stake, the energy footprint of a global blockchain network is significant. That's why there's ongoing research into more sustainable consensus mechanisms and ways to optimize the network's energy usage.
It's encouraging to see that sustainability is a key consideration for Ethereum's future.
And then there's the complexity.
Yeah, you hit the nail on the head. Ethereum can feel incredibly complex for newcomers with its technical jargon and ever-evolving technology.
That's a valid concern. One way to address this is through better education and resources. The Ethereum community is already doing a great job of creating tutorials, documentation, and user-friendly interfaces.
Making the technology more accessible is crucial for wider adoption.
Absolutely. As Ethereum matures, we can expect to see more intuitive tools and platforms that abstract away the complexity, allowing users to interact with the network seamlessly.
So despite the challenges, the future of Ethereum looks incredibly bright.
Indeed. The potential for this technology to transform industries and empower individuals is immense. We've only just begun to scratch the surface of what's possible.
It's been an incredible journey exploring Ethereum with you. I hope our viewers feel more informed and excited about the possibilities that lie ahead.
We encourage you to continue learning and exploring this fascinating space. There are countless resources available online and a vibrant community eager to welcome newcomers.
Absolutely. And if you have any questions or thoughts, please share them in the comments below.
We love engaging with our audience and fostering insightful discussions.
And if you found this deep dive valuable, don't forget to subscribe to our channel, Web3 Reviewer, now for more explorations into the world of blockchain and beyond.
Thanks for joining us.
Until next time.